everyone. Myself A. Rajalakshmi, Assistant Professor from the Department of Information Technology from Tech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. Today we'll see about the subject Foundation of Data Science, and in that we'll discuss about Unit 4, which is Python libraries for data wrangling. The term data wrangling means converting a raw or messy data into a structured format. This process is also called as data munging. For converting, we'll use Python libraries. We'll discuss about the topic. The first topic is basics of NumPy arrays. Categories of basic array manipulations are attributes of array, which determines the size, shape, memory consumption, and data types of array. Then indexing of arrays, getting and setting the value of individual array elements. Then slicing of arrays, getting and setting smaller subarrays within a larger array. Then reshaping of arrays, changing the shape of a given array, which means 3 cross 4 matrix, 4 cross 5 matrix, like that. Then joining and splitting of arrays, combining multiple arrays into one and splitting one array into many. Then computation on NumPy arrays, which is called as universal function. The universal function refers to element-wise operation that are applied to NumPy arrays. These functions perform fast vectorized computations without the need for explicit loops, making them highly efficient. The universal function exists in two flavors: unary U functions, which operates on a single input, and binary U function, which operates on two inputs. We'll see the example. Example without NumPy is data is equal to in array 1, 2, 3, 4, and the result will be array of x square for x in data. Then example with NumPy is we are importing NumPy as NP, then data is equal to NP dot array 1, 2, 3, 4, then result is equal to data into 2. Then some other examples are for adding we'll use np dot add, then for subtracting we'll use np dot subtract, for unary negation we'll use np dot negative, for multiplication we will use np dot multiply, for division np dot divide, for floor division we'll use np dot floor divide, then for power or exponentiation we'll use np dot power. We'll see the example in Python. Import NumPy as NP. We are giving two arrays. Array 1 is equal to np.array 10, 20, 30 and 40. Then array 2 is np.array 1, 2, 3 and 4. Now we are going to perform addition operation. So add result is equal to array 1 plus array 2. Then for subtraction array 1 minus array 2. Then for multiplication array 1 into array 2. Then for division array 1 divided by array 2. For floor division we are using array floor division of array 2, and for finding modulus, and the last one is for finding exponentiation. The next topic is absolute values. The absolute value of a number is the non-negative value of that number without regard to its sign. You can compute the absolute value using the built-in abs function. ABS function is input x is equal to np dot array. We are giving 5 elements minus 2, minus 1, 0, 1 and 2. Then ABS of x or np dot absolute of x. Then the result will be all in positive, like 2, 1, 0, 1 and 2. We can also perform trigonometric functions. So theta is equal to np dot linspace 0, np dot pi, 3. Then we are printing theta is equal to, we are also performing sin theta, cos theta and tan theta. We can use exponential function also. So power or exponentiation 2 power x or 3 power x, like that. Then the last one is finding the logarithmic value. Mm, mm. Here we'll see the examples. X is equal to np dot array for absolute value. The all will value are displayed in positive numbers. Then for theta, we are calculating theta value, then sin theta, cos theta, then tan theta. And also we are finding the exponentiation values too. And the next topic is aggregation function. An aggregation function is a mathematical operation that processes multiple values from a data set or collection and returns a single summary value. Aggregation functions are essential in data analysis and processing to extract meaningful insights from large data set. Here some of the aggregate functions are np.sum, then np.product. The term NaN means it is not a number. Then for finding mean, np.mean. For standard deviation, np.std. For finding variance, np.var. For finding the minimum value, np.min. For maximum value, np.max. For finding the index of a particular minimum value, we'll use np.argmin. And for max, np.argmax. And for finding the median, np.median. And for finding the percentile, np.percentile. Then np dot any elements are true, then to evaluate whether all elements are true, that is called as np dot all. The next topic is computation on arrays. Broadcasting is a powerful feature in NumPy that allows for operations on arrays of different shapes and sizes without needing explicit loops. It automatically handles the alignment of arrays so that arithmetic operations can be performed element wise. We are having the some of the rules of broadcasting. Broadcasting in NumPy follows a strict set of rules to determine the interaction between the two arrays. Rule 1 is if the two arrays differ in their number of dimensions, the shape of the one with fewer dimensions is padded with 1 on its leading left side. Then the rule 2 is if the shape of the two arrays does not match in any dimension, the array with shape equal to 1 in the dimension is stretched to match the other shape. Then rule number 3 is if any dimension the sizes disagree and neither is equal to 1, an error will be raised. Here you will see the visualization of NumPy broadcasting. For np.array we are having three columns 0, 1 and 2, and for adding we are having only one columns. So we'll use this 5 to add with other three elements. So 5 plus 0 5, 5 plus 1 6, then 5 plus 2 7. Likewise for the next step. We are adding the 3 cross 3 matrix with 1 cross 3 matrix. So here you will get the answer as 1 1 1 and 2 2 2 and 3 3 3. While adding this 0 plus 1 and 1 plus 1 and 2 plus 1, we are padding the remaining two rows as same as that one, row 1. The next slide is about importing NumPy as NP for creating the two-dimensional array. Array is equal to np.array. We are creating two-dimensional array. Array 1 is 1 2 3 and array 2 is 4 5 6. We are adding a scalar array to add with that particular array. Result is equal to array plus 10. We are printing array after adding scalar comma result. Your result will be we are adding that particular 10 to each array elements. So 10 plus 1 11, 10 plus 2 12 and 10 plus 3 13. Likewise for 10 plus 4 14, 10 plus 5 15 and 10 plus 6 16. The next example is creating a 2D array. Array is equal to np.array 1, 2, 3, 4, 5, 6. Then we are creating a one dimensional array. Vector is equal to np.array 10, 20 and 30. The result is adding array plus vector. So after adding, he will get the 10 plus 1 11, 20 plus 2 22, 30 plus 3 33. We are adding each element to that particular array elements. So likewise for 4 5 weeks, 10 plus 4 14, 20 plus 5 25 and 30 plus 6 36. The next slide is import numpy as np. Likewise we are creating a same 1 2 3 array 1 1 2 3 4 5 6 and array 2 as 10 20 and 30 and 40. As the array size is not equal, not similar to each other, it cannot be broadcasted. So the results will be, it is an error. Operands could not be broadcast together with shapes 2 comma 3 and 2 comma 2, which means 2 cross 3 matrix, and the another array is 2 cross 2. So we can't perform any operations with the above two arrays. The next topic is comparison, mask and Boolean logic. Comparison. It involves evaluating the relationship between elements of arrays or between arrays and scalar values. In NumPy, comparison operation return arrays of Boolean values, which is equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. We'll see some example. We have executed all this program in Jupyter Notebook. You can also try with other compatible options. So import numpy as np. First we are creating an array. Array is equal to np.array 1 2 3 4 5, and we are performing the comparison operator. First one is equal to 3. So if anything equal to 3 means the output will be displayed as true. Then greater than or equal, greater than 3. So for greater than 3 we have 4 and 5. For that particular 4 and 5, the output will be true and true. For the comparison condition, less than or equal to 3. So for the first three values 1 2 and 3, you will get true as answer, and the remaining for 4 and 5 you will get false as answer. The next topic is mask. Masks are Boolean arrays that are used to filter or select elements from an array based on some condition. Masks are the results of comparison operands and can be used to index or filter data. Which is similar to the previous topic. So we are creating an array. Array is equal to np.array 10, 20, 30, 40 and 50. Create a mask for values greater than 25. So for greater than 25, we are creating a mask, like we are filtering it. So mask values greater than 25. So first, for the first 10 and 20 value, it will be returned as false, and for the next 30, 40 and 50, it will be displayed in the next condition, and it will be displayed as true. The next topic is Boolean logic. Boolean logic involves operations that combine multiple Boolean arrays or values. NumPy supports logical operations such as AND, OR and NOT. The common Boolean functions are np.logical AND, logical OR, logical NOT, and finally logical XOR. We'll see the example. For array 1, we are creating true, false, true, false. Then for array 2, false, true, true, true. We are performing Boolean operations, and result is equal to np.logical and, which will compare array 1 and array 2. If both the conditions are true, then the output will be true. So true for and. For or, if both the conditions, if any one thing is true, and the output will be true. If any values in array 1 is true or array 2 is true, then the output will be true. For logical not, it will be displayed as false, true and false, true. The next topic is fancy indexing. Fancy indexing means passing an array of indices to access multiple array elements at once. Types of fancy indexing, which is indexing or accessing more values, array of indices in multidimensional, then standard indexing. For example, consider the following array. A structured array allows you to define custom data types, each consisting of fields with their respective data types. It is useful for situations where the data contains mixed types like numbers, strings, or data. We'll see one example. Import numpy as np. We are defining a structured data type with fields name, age, and salary. Then we are also creating a structured array of employees. Employees is equal to np.array. Employee details like Alice and his age and his salary. Then for accessing individual fields, we are using name of employees, ages of employees, and salaries of employees. Then finally we are going to print the first employee and the name of third employee. The name of in the output will be the name of the employees are in the format Alice, Bob, and Catherine, and the ages of employees are 25, 30, and 28 respectively. Then salaries of employees are 50,000, 60,000, and 65,000. And finally, for printing the first employee details, the first employee details will be Alice, 25, and 50,000. The name of third employee is Catherine. The next program is displaying the values. We are creating a series. Data is equal to pd. Pd means pandas dot series 0.25, 0.5, 0.75, 1.0. It will automatically displays it with indexing. So default indexing will start from 0. So you will get for 0th place 0.21, for 1 0.50, for 2 0.75, and for 3 1. When for displaying only the values, we'll give data dot values. The output will be in arrays, array of 0.25, 0.5, 0.75, and 1 respectively. Then for retrieving a particular value using index means data of 2. In the place of 2, the output will be 0.75. Then for retrieving the value using index, we are also using data of 1 is to 2, 3. So 1 is to 3 means it will filter from index 1 and index 2. So the output will be 0.50 and 0.75. Then for data is equal to pd dot series. The series will be 0.25, 0.5, 0.75, and 1.0. The index will be w, x, y, and z. So it will be displayed as for w 0.25, for x 0.50, for y 0.75, and for z 1. For population dictionary, we are going to create a dictionary. So for California city, the area size will be given as 38332521. For Texas, and for New York, for Florida, and Illinois respectively. We are creating a series about the population, and we are printing it. Then we are going to display about a particular city population. So population of that city name will be displayed here. So 19552860. Then we are going to create a dictionary for scalar value. Pd dot series 5 comma index 10, 100, 200, and 300. For each 100, 200, and 300, the scalar value will be displayed as 5. Likewise, we have tried some other problems too. Then in the previous slide we have given a population. In this slide we are going to give an area. So we are combining states, population and area as like a table. So the code will be states is equal to pd dot data frame. Data frame means a table like structure. So population is to population, area is to area. Then we are going to display about this particular state variable. Output will be in like a row and column format. Then we are going to display only the states, state dot index. Then only the state will be displayed: California, Texas, New York, Florida and Illinois. We are going to display only the columns. So index of population, area, and we are going to display the area size. So city name and its respective area. And the next line is pd dot data frame. A is to 1, B is to 2, and the next array B is to 3 and C is to 4. In the first array C value is not mentioned, so it is given as not a number, NaN value. In the second array A value is not given, so I am mentioning it as not a number. The next program is import numpy as np. We are going to create a random state, random integer with size of 100. So it will create a random integer of 10 values, 10 elements. So we are accessing three different elements: x of 3, x of 7 and x of z. So in the third place it will be 71, in seventh place it will be displayed as 86, and in 14th second place it will be displayed as 14. So can pass a single array of indices for one dimensional array too. So 3, 7 and 4. The output will be 71, 86 and 60 respectively based on the particular index. We can also pass a single array of indices for two dimension. So for two dimension, the index number is 3, 7, 4 and 5. The output will be 71, 86, 60 and 20. The next line is x is equal to np dot a range of 12. So a range of 12 means it means 3 cross 4 matrix. So we are going to display the 3 cross 4 matrix. Then we are going to print the values in rows, then in columns. Likewise we can perform any operations using this Python. We can combine fancy indexing with slicing. We can combine fancy indexing with masking. We can also modify values with fancy indexing. Likewise we can perform any operations. Then we can perform sorting. We can index. So in the last state we are going to generate a random integer of values between 0 comma 10 and with 4 rows and 6 columns. The output will be in this format, the final, and which can we can also sort each of the row. Then we can create a series as dictionary. Likewise we have mentioned in that population and area slide. So import pandas as pd, data is equal to pd dot series. So we have given four values. So index name will be a, b, c and d. So if the index value is not mentioned, it by default it will take it as 0. So we are displaying data of b. A in data is present, so the output will be true. F in data is false. We have not given any f value here, so f in data will be false. So data dot keys, what are the keys it have? A, B, C and D. If we want to add a new item, we can also name it as data of E, and the value will be 1.25. So we can also add, we can also slice by explicit index, we can also slice by implicit integer index, and we can also mask a particular data or fancy indexing or filtering a data. So based on the index value, we can perform any operations. So this is another one example for creating a data frame, the same as like we have seen in California's, like California population and cities, like similar one. The remaining all examples are based on this data frame alone. Hope you all have understood the topics, and if you have any doubts you can clarify. So this is one of the easy subject. You can score and learn something in this subject. Thank you.